Okay, good morning children once again. We have already covered two videos as far as the first chapter is concerned. So if you remember correctly, we have discussed what a physical quantity is and what are the different types of units, the systems of units. We had taken up some examples of the fundamental units as well as the derived units. Okay. So now one more thing that we have to cover as far as the units are concerned is a compound unit. Okay. So what is a compound unit? Please read carefully over here. It is a unit which is formed as a result of multiplication or division of any two units. Okay, so a compound unit will either be a multiplication of two units or a division of two units. Now, an obvious question that will arise in your minds after reading this statement is that then what is the difference exactly between a compound unit and a derived unit? Because if you remember correctly, in derived units also we had said that a derived unit is a combination of two or more fundamental units. Okay, so here also we are saying that compound units are formed as a result of multiplication or division of two units. Okay, so what is the exact difference? So the difference here is that if you remember in derived units were a combination of fundamental units only. Okay, so if we have, let's say for example, the unit of speed, which is like meters per second. Okay, so that is a derived unit because it has been taken from meters and it has been taken from seconds. Okay, so both of which are fundamental units. Whereas if you see over here, these are some of the examples of the compound units that I have listed. Example, unit of torque. Now torque as a physical quantity you will study in detail in 10th. For the time being, you note that this is the turning effect of force. Okay, so the SI unit of torque here, if you see, is Newton meter. Okay, now obviously this is a multiplication. As you can see, these are the three different ways of writing the compound units. We will either leave a space between the two units, or we will put a multiplication sign between the two units, or simply we will put a dot between the two units. Now the big question is, what is the nature of these two units from which the unit of torque has been achieved? So if you see, meter is a fundamental unit, okay, whereas Newton is not a fundamental unit. Newton itself is a derived unit. Okay, so the difference when we talk in terms of the difference between a compound unit and a derived unit is the only fact that in a compound unit you can have a combination of one derived unit and one fundamental unit also. Okay, essentially they both are same because ultimately it is going to be the combination of two or more units. It can either be the multiplication, like for example in this case, okay, or it can be the division of two units. So in case of division, here is another example. If you can see, similarly the unit of power is joules per second, or joules second to the power minus 1. Now how do we get a general idea of what the unit of a particular physical quantity will be? Let's suppose that we did not know what is the unit of power. So if you do not know the unit of a physical quantity, the first thing that should come to your mind is the formula. Okay, so suppose we have the formula for power as rate of doing work. So we have W upon T. Okay, now work done has a unit of joules, whereas time has a unit of second. So you can either write joules per second, or you can write, when second goes up, you have second to the power minus 1. This is basically a mathematical concept that you will study in currently in this year in the chapter indices. Okay, so here the unit of power has been derived as obtained as joules second to the power minus 1. Once again you see, is it a combination of two units? Yes, it is a combination of two units, joules and seconds. In fact, it's a division of these two units. Okay, so it is a compound unit. Why? Because we have second as the fundamental unit, we have joule as the derived unit. Okay, so it is a combination of two units. In fact, it is the division of 2 units. Okay, so this is what the compound unit is. Now, one more thing that you must be wondering about over here is that we are using small letters for denoting some things, whereas we are using capital letters to denote some other units. Okay, so now here is the point that you have to keep in mind. It is important to note here that units which have been chosen after the names of scientists are to be written in capital letters. Okay, if you see over here, this I have represented N in capitals because this N, capital N, stands for Newton, which is again the name of the famous scientist Sir Isaac Newton. Okay, so Newton obviously is the unit of force. So those of you who are going through the revision in the book, or maybe perhaps if you don't have the book, I have today I have uploaded some of the initial snaps of the few pages of the book. Okay, so you can go through them. Okay, similarly, now also capital W represents the SI unit of power. Okay, why capital W? Why not small w? Because, and it is in capital letters because of the scientist James Watt. Okay, so since Watt has been derived from the name of the scientist, therefore symbolically we will always use a capital letter in such cases. There are numerous other examples also. I have taken up a couple of them over here. You have Pascal also, the unit of the SI unit of pressure. So you can go through all those things in the from the book. Okay children, now just to make you work a little easier to understand, and so that you now go ahead and start practicing a few questions also from the amount of content that has been covered till now. Okay, we have taken a couple of examples, or you can say questions, the type of questions that you will find in the exercises in the book. Okay, so let us have a look at question number 1. Size of a particle is 4.6 microns. Okay, so this is this mu symbol, if you remember, we have already used it in, I think, the second video. Okay, it is a representation of one of the smaller units of length. Okay, so you can say size of a particle is 4.6 microns. So express it in SI units of length. Okay, now this symbol over here is not just used in terms of length. Okay, it is not just used as a prefix for the units of length. It can also be used in terms of the units of time, for example microseconds. Okay, similarly over here it is micrometers, since in the second half of the question you see express it in the SI unit of length. Okay, so if you see the relationship, this is something that you have to remember. Okay, so 1 micro is equal to 10 to the power minus 6 meters, or you can also say 1 micrometers is equal to 10 to the power minus 6 meters. Okay, so and obviously meter is the SI unit of length. Okay, so if 1 micron is equal to 10 to the power minus 6 meter, therefore 4.6 microns will be equal to what? Simple mathematics, you multiply 4.6 multiplied by 10 to the power minus 6 meters. Okay, so your answer 4.6 microns is equal to 4.6 into 10 to the power minus 6 meters. Okay, that is your answer to the first question. Now you have a look at the second question quickly. How are the following derived units related with the fundamental units? Okay, so there are 3 of the derived units that have been written over here. The first one is Newton, then Pascal, then Joule. Okay, so so now before we actually go ahead and solve this question, let us have a look at a very peculiar thing that some of you might notice over here. Just now I had mentioned that if we are using a unit which is named after a scientist, it is to be represented symbolically with a capital letter. Whereas over here, if you see this Newton with an N, Pascal with a P, and Joule with a J, they are all in small. So the difference, please note over here, is this is not the symbolic representation of the unit. Okay, this is the full unit name that we have written. Okay, this is the full spelling Newton, this is the full spelling Pascal. Similarly, this is full Joule spelling. Okay, so when we are writing the full name of the unit, there is no need to write the first letter in terms of capital letters, whereas if you are using the symbol of the unit, okay, so for example, if you use the unit of, if you use the symbol of this unit Newton, you will write capital N over here. Okay, similarly for Pascal, you will use a capital P. Okay, and similarly for Joule, you will use a capital J. Okay, so we have capital N, which is the symbolic representation of the unit of force. So, and since it has been named after the scientist Newton, it will be represented with a capital N. Similarly, Pascal, it will be PA. Okay, where P is in the capitals. Okay, because obviously again it is after the name of a scientist. Similarly, Joule with a capital J. That these are the symbols which denote the units. Okay, they should be in capital letters, whereas the full names need not be in capital letters. Okay, so now coming back to the solution of the question. The question was, how are the following derived units related with the fundamental units? Okay, so Newton, as we know, it is the unit of force, the SI unit of force, and the formula for force is mass into acceleration. You will study that a little later in this year. Okay, force is mass into acceleration. The SI unit of mass is kg. If you remember, we have just studied that in the previous few lectures. Acceleration unit is meter per second square. Okay, so now if you see carefully, this kg, this meter, and this second, these are all fundamental units. Okay, so going by the formula, there is a multiplication sign. Okay, so when we combine the unit, overall unit, the overall unit for force will come out to be kg meter per second square. Kg meter per second square. Okay, or this can also be written as, when you want to, if you want to take this second square up in the numerator, it will become kg meter second to the power minus 2. Once again, the reason why we have a minus over here is because we are taking something from the denominator to the numerator. So as a rule, as an indices rule in mathematics, the sign of the power changes. Okay, so if it was plus in the denominator, plus 2 in the denominator, it will become minus 2 in the numerator. Okay, similarly, now coming to the second part, which is Pascal. Pascal is the unit of pressure. Pressure has a formula, force per unit area, force upon area. Now there is a big table that is given in one of the pages in the first chapter. I have given you that copy of that page, so please go through it. You will find all the relevant formulae over there. Okay, so talking in terms of pressure, the formula is force upon area. Force has a unit Newton, area has a unit meter square. Now Newton we have already seen over here in the first part. Newton has been derived from kg meter per second square. Okay, and meter square obviously is already in terms of meters, which is fundamental unit. Okay, so now when we combine, if we use the full formula, force upon area, so we have to divide these two units also. So kg meter per second square divided by meter square, you get kg per meter per second square. Or if you want to take this meter and second square up in the numerator, it will have m to the power minus 1 and s to the power minus 2. Okay, so Pascal, which was a derived unit, has now been represented or related in terms of these fundamental units. Which fundamental units? Kg, meter, second. Okay, similarly, going to the third part, which is Joule, which is the unit of work. Okay, so work done, again the formula is force multiplied by the displacement. Okay, force we have already seen over here. In terms of the fundamental units, force can be written as kg meter per second square and multiplied by displacement. Displacement has an SI unit of meter. Okay, so when we multiply these two, you will get kg meter square per second square. Okay, so this joule, which is a derived unit, has actually been represented or related in terms of the fundamental unit. Okay, so these are the fundamental units that were required according to the question. Okay, so I hope that the discussion in these 10-15 minutes of the video will help you in actually going ahead and solving a few examples or a few fill in the blanks type questions and a few one line questions that are given as a part of exercise 1A in your book. Okay, so in as far as the first chapter is concerned, we have more or less covered the exercise 1A. Okay, now I would like everyone to thoroughly revise till what we have done till now. Okay, so that you can solve a few questions also. Okay, thank you.